Hi guys, welcome to the session. In this video, we are solving CAT 2024 slot 1 quantitative abilities, and this is a number theory question. The subsection is remainder theorem. Now in remainder theorem, this is particularly taken from the idea of Fermat's little theorem, or you can also call it Euler's theorem. Okay, I'll briefly explain you what Fermat's little theorem or Euler theorem states. So a number when divided by n is any number. Okay, in this case x and n have to be co-prime. Okay, then if this setup is raised to n minus 1, then the remainder will be equals to 1. Either you can understand it like that. There is an advanced version of this, which is the Euler's theorem, basically the same Fermat's little theorem, but in case of the denominator being a, let's say, numerator and denominator combination being a co-prime this thing, if you, let's say, in the denominator have a composite number, in that case you can find the Totient number or the Euler number and you can apply the same setup. Okay, I'll explain that also. So in that, what we need to understand is that if x by n is raised to, let's say I'm using any variable, that is phi generally is the totient function or totient number of this thing, then also the remainder will be 1. Okay, now how do we calculate phi? I have elaborately discussed this in our theory classes, that there is a method through which we can calculate phi for composite numbers. Luckily for us, if it is a prime number, the totient number or the totient function comes out to be 1 less than the number itself. So in this question, since they have said that 10 to the 100 is divided by 7, 7 being a prime number, we can directly use phi as 6. So if I can, modify the question in such way that the index is broken down into the powers of 6, the remainder will come out as 1. Okay, let's see if we can do that. So the question, I'm retracing it: 10 raised to the power 100 by 7. I know I need to somehow make modifications to get to the answer. The first modification that I'm going to make is that I will raise 10 to the power of 6 to the 16. 6 into 16, or 16 6 are 96, divided by 7, remainder, into the 4 tens that are left. I'll put that outside, so 10 to the 4 by 7 remainder. Now this thing is separate. We can do this thing, we can split the numerator, that is allowed. Now you have to understand that this part, by the very virtue of Fermat's little theorem or Euler's theorem, the remainder will come out as 1. So we need not worry about this part of the expression. Now we just need to worry about the other part of the expression, that is 10 to the 4 by 7. Now 10 to the 4 by 7 is not a very difficult number to calculate. What we can do is that we can further disintegrate tens. We can do 100 into 100 and then divide. One beautiful method would be, let's say, dividing 10 by 7. So 10 by 7, the remainder comes out as 3. So this thing can further be disintegrated as, I can write it, 3 by 3 to the 4 by 7. These things are allowed. Okay, hopefully you can see it. 3 by 7 to the 4 is allowed. Now at this point you need to be careful. Please understand, we are calculating the remainder. We are not actually calculating the value of anything. Remainder is getting calculated. So 3 to the 4, you know what that is. 9 nines are 81. So 81 by 7. Now this calculation is not, this division is not difficult. You can do it orally also. I'm doing it just for the sake of this video. So sorry, this is 4. So the final remainder comes out as 4. So you can see that since we have been able to disintegrate this entire thing into smaller and smaller numbers, finally the number that we are getting, 81, that one gets divided by 7, the remainder is 4. So the final remainder to this question would be 4. Now I took some time to explain the theory a little bit. You really did not required the theory. You could have just gone and transformed this 10 raised to the power 100 as 10 to the powers of 6 raised to the powers of something else, so that we can directly apply the Euler's theorem or Fermat's little theorem. Whichever one you are comfortable with, you can use x by n to the p, or whatever you call it. Finally, this is a very easy question, simple question. I don't think this would have taken more than 1.5 minutes, maybe 2 minutes. Okay, so that's it. Thank you.